Good morning, everyone, and thank you for attending. I'm excited about our 2.5 release and to have Glen Kosaka, VP of Product Management at NeuVector, here as our speaker. Glen will highlight vulnerability management from build to ship to run, implementing admissions control to prevent unauthorized deployments, complete runtime security with process, file systems, and network protection, and to go over automation for deployments and updates. Towards the end of the presentation, we'll open up for Q&A. So if you have any questions, feel free to write them in the chat box as we go through the presentation. Okay, Glen, would you like to take it from here?
All right, thanks, Young, and thank you everyone for joining us today. So today I'm going to go into a little bit more advanced topic, which is automation and how you can build security into your container pipeline. I am going to use NeuVector as an example in terms of showing how that integration could occur, but I won't go into a complete demo of NeuVector, and you can certainly contact us later for a more detailed demo of NeuVector. And I will highlight some of the latest automation features that were in our most recent 2.5 release. All right, so if we start at the top, many of you are building your container CI/CD and lifecycle pipelines and trying to automate as much as possible so that you can do a release a day, 10 releases a day, 100, or even 1,000 releases or updates a day automatically. And in order to do that, not only do you have to automate your entire CI/CD and build, ship, run pipeline, but it's critical to automate the security aspects of that as well, because you don't want to have some new service or a change of your service get deployed and find out after you've been hacked that your automation did not include the appropriate security policies or scanning required to protect those when they got into production. And it's a big bad world out there with a lot of potential attacks. The scale, just the sheer scale of the number of containers and services being deployed, and the explosion of all of the container to container traffic, all of the system traffic that's generated, makes it very difficult to see what's going on. And traditional tools really can't help you to see the network traffic between pods or ingressing and egressing out of them, as well as what's going on in those containers. Are the proper processes running, or is there suspicious file system activity? So not only can there be vulnerabilities introduced with open source software, but it could be other application layer attacks for your custom applications, or even if you've bolted everything down and removed all vulnerabilities, it could be a sophisticated insider attack that is able to get into your infrastructure and then move around. So the question is, how do you automate security to be really so that the security team and the security process is not holding up your pipeline and preventing you from deploying 1,000 releases a day, limiting you to maybe one a week. So when we talk about automation, I'm going to kind of talk about 3 different areas. Automation of the creation of your Kubernetes cluster or your container cluster, the tools needed to manage that cluster and secure it, and then the actual application workloads themselves. So if we start with the clusters themselves, with the public cloud services, AWS, Azure, Google, IBM, all offer managed Kubernetes services, which make it very easy to automate the deployment of new clusters, managed clusters. But even if you're not using those public cloud services, you can automate the deployment of a new cluster for your on-premise deployment as well. That's not the topic of what I'm going to talk about today, but just so you know, there are tools for you to be able to do that. if your infrastructure requires you to dynamically spin up a new cluster and then take it down. Now, once you got that cluster up and running, whether you're using AKS or an on-prem, you're going to have to make sure that your orchestration tools, Kubernetes or Rancher OpenShift, are also deployed automatically and have the proper RBAC controls and things like that set up. In addition, there's a lot of excitement about service meshes, so deploying an Istio or Linkerd 2 service mesh on top of that can also be automated. And then there's a number of tools which need to be automatically deployed as much as possible into that cluster. And so one of those tools, which I'll talk in depth about today, is the NeuVector Container Security Platform. But there could be other monitoring tools, Fluentd, Prometheus, and other tools that you use to manage and monitor your cluster. And then finally, the application workloads have a pipeline of their own for rapidly and automatically deploying new workloads or updating existing workloads. Now, how that's important to the security aspect of that is, as much as possible, when new workloads are deployed or existing workloads are updated, you want to make sure that you've integrated security into that process as well, so that the appropriate security policies for protecting them and evaluating them, scanning them as well, are then fed back into your security platform, either right prior to deployment or right after they're deployed. So if we take the first topic of automated tool deployment, if you're spinning up a cluster, you also may want to automatically deploy security tools like NeuVector. And you'll hear a common theme that I talk about today, which is to leverage the built-in mechanisms that Kubernetes and the orchestration platforms provide. Because if all of your tools leverage those and you don't have to build custom scripts or tools outside of that, then you're going to be able to maintain that environment, especially as new releases come out of Kubernetes and OpenShift and Rancher. So it's critical in order to really truly have a cloud native security solution, to make sure that it's leveraging all of the built-in features of the platform. So there are three that I mentioned here. One is just plain kube control commands. It's kind of a hybrid manual and automated process where you're running kube control commands. But the automated part of that is that when you use the sample manifest to deploy NeuVector, we're going to automatically create the services, the routes, the mission control webhooks if needed, the deployment of all of our manager controller containers, and as a daemon set, our enforcer container, which will monitor and protect each worker node in your cluster. And so leveraging that will bring some level of automation to your environment. Even more automated would be using the Helm chart to deploy your NeuVector containers. And Helm makes it easier to specify certain configurations during the deployment, and especially to be able to update those and know how to update those when things change. And then finally, one of the features we've added in the 2.5 release is the support for Kubernetes config maps. And config maps really enable you to pre-specify a number of configuration options that are going to be customized to NeuVector, so that when the deployment of NeuVector occurs, that all of the other configuration information, I mean, you could see some of the entries here, for example, your LDAP integration, so your user and role-based access controls can be set up. Of course, your license key can be administered. All of the integrations that you need with syslog or other monitoring tools can be configured so that NeuVector comes up and running, is integrated, and is protecting your environment, or ready to protect your environment as soon as you deploy. There's no need to manually log in and do all these configurations, or manually import a config file. So once your orchestration platform and your tools are deployed, then you can work on your application pipeline and taking a look at the full life cycle of your application workloads. So in the build, ship, and run framework, that often starts with building the images in the dev process. From a security standpoint, we're going to look for integration points where we can integrate security into these phases of your pipeline. So in build, it's scanning during the build process. So for example, using a Jenkins plugin to do that, or once the images are put in a registry, a staging registry or dev registry, to scan those images at that point. There are more advanced tools that you can use even before that to do code analysis and to even do a full open source auditing and management solution. And we partner with companies like Black Duck Software to do that type of in-depth analysis. Now, once you're getting ready to launch and deploy your images, what's critical at the next step is to look for admission controls, which can help you define policies as to what types of images and pods are allowed to be deployed and who can deploy them, from what registries can they be deployed, what vulnerabilities are you willing to accept in a production environment. Now, in addition to that, it's in preparation for the runtime environment, there's all of the access controls, host and kernel security, secrets management, and all the pod security policies that need to be put in place. And so those can be all integrated and automated through your orchestration platform. And then NeuVector can provide an auditing of all of those settings with the Kubernetes and Docker CIS benchmarks. And then once you're in the production environment, it's critical to be able to automate the protection, the runtime protection for your workloads. And so that's going to really focus on the network, making sure you have the network visibility, the appropriate firewall rules in place. Even if you're deploying a new service, making sure that those rules are active to protect your workloads. And then the container protection part of that is to really be able to inspect and baseline all the processes and file system activity that could occur in a container, making sure that if there are baseline rules to allow processes to run, that those are all set up and configured before you deploy your application workloads. And then rounding that out, monitoring the host, of course, is critical. And then doing another scan, vulnerability scan during runtime, just to make sure that you know what vulnerabilities are existing in the production environment, as well as if any container is modified somehow while it's running in production, that there is the ability to scan it for vulnerabilities. Also, vulnerability scanning is not just important for the containers running in the runtime environment, but also the hosts themselves and the orchestration tools, whether it's Docker or Kubernetes. We've all heard of the critical vulnerabilities that were discovered in the Kubernetes API server, kube control, as well as the Docker runtime. And then finally, automated response rules to respond and communicate any security events, to take immediate action. Those can all be automated as well. So that's an example of the pipeline. Now let's take a look at the early parts of the pipeline. As we talked about in the early stages of dev, you can use tools like GoSec, Black Duck, or JFrog to do the SAST and code analysis. And then as you move into the CI/CD phase, there are build and integration tests. Now in this context, SAST scanning is vulnerability scanning during the build process. And there may be some project standards and coding standards that you need to run tests against your images as well in that CI/CD process. So these are all points at which you can integrate security. Now with NeuVector, we're able to integrate into the build phase. whether you use a Jenkins plugin to specify a policy to fail the build, or a Circle CI orb if you're using more of a SaaS-based build solution like Circle CI. You can trigger the vulnerability scan during your build process, and then you can fail the build if it matches certain criteria. Could be the number of vulnerabilities or specific CVEs that you're looking for. For any other tool chain, you can use the REST API combined with your own custom logic for triggering the vulnerability scan during the build phase. Now, typically, after you've built the image and it's passed that initial scan, you're going to store them in maybe a staging registry or even a production registry. Now, at that point, it's important to do the layered image scanning of repositories. So to monitor your staging and production repositories, to be able to detect when there are new images in there, as well as to be able to scan them and do a layered scan of them. What the layered scanning in our 2.5 release enables you to do is to see all of the different layers of the image, as well as the commands used to create those layers, so that if you need to get back to the developer to point out specific vulnerabilities that should be addressed, it's much easier for the developer to tackle that. And these scans can be either scheduled or they can be triggered in the case of OpenShift image streams, which offers the capability that anytime a new image or an updated image appears in the OpenShift registry, it will automatically be scanned by NeuVector. So you've done your build and your registry scanning, and then the next step in the pipeline as far as security goes is to define some admission controls. And with admission controls, you're going to make sure that unauthorized or risky images are not allowed to be deployed, or conversely, that only images from a identified registry are allowed to be deployed. Different criteria can be used to allow or deny deployment. Those could be based on vulnerabilities, namespaces, registries, whether a container is root or privileged, or even custom labels that you put in there. And again, it's critical to be able to integrate with the orchestration platform and some of the capabilities they provide. So we are integrating with the Kubernetes and OpenShift admission control webhooks, so that when a deployment occurs, Kubernetes will stop that, wait for NeuVector to check its policy, and then allow that deployment to occur. So I'm going to jump into the NeuVector console, and you can see here we're discovering all the containers that are already running. We're starting to build our runtime policy, and I'll explain a little bit more about that later. Let's focus right now on the registry scanning capability. So we can see here that in my demo repository, I've scanned my Node.js containers, and I can see that there's different layers of vulnerabilities that occur, and see what commands were used to build those layers. So if I do need to remediate those and then have them repushed and rescanned, I can do that very easily. So now that I've scanned the images, I can define an admission control rule that says if there's more than 5 high vulnerabilities, block this deployment. So if I go into my demo system here, first of all, I can show you, the pods that are running right now in my demo environment. I've got another set of pods that I'm going to try to run in a different namespace. I'm going to show you my deployment for this one. And basically, I'm going to deploy 3 Node.js pods into a namespace called admission demo. So let's see if I do it. All right, so I'm trying to deploy this, these 3 pods, and you can see I get an error here, and it's showing that the admission webhook for NeuVector denied it, and that was blocked. So you can see here that it hit that rule, and if I go into my notifications under risk reports, I can see that my admission control denied triggered this event. And again, this can be notified into your SIM system. We could build other response rules based upon this event. But you can see here the rule number that was hit to deny this deployment. Now let's go in there and let's say that I do want to allow deployments into my admission control namespace, but I want to block it from other namespaces because my admission control namespace is really my test namespace. So I want to allow that. So I can say namespace is not one of admission demo, and I can add that as a criteria. So what I'm going to do here is I'm going to allow high severity CVEs if the namespace is admission demo. I'm only going to enforce this rule if it's deploying into other namespaces. So if I do the same activity there, you could see that, well, I already had the service existing, but you can see my pods are created, get pod dash n. So these are the pods that are being created in the environment. And you could see under the notifications here, risk reports, that these containers have started, and NeuVector has automatically started to scan those containers during runtime for vulnerabilities. All right, so that's a quick demo of admission controls. Now let's move on to the next phase. Let's say I've deployed my workloads into production. So we're going to focus on the staging, production, and post-production phases now. So in the staging phase, we're going to, as we just did, we're going to make sure our admission controls are working. We need to verify and deploy our security policies and then deploy our application workloads and then run our automated tests. And the automated tests will not only test application functionality, but it will generate the network traffic as well as the processes and containers that NeuVector can learn to build an application security policy. And the same thing is going to happen in the production environment. And in the production environment, we're actually going to be enforcing the network security, host and container security, and then integrating monitoring and logging. So the reason that it's so critical to make sure you have very in-depth runtime security is that a typical attack or an exploit is not comprised of a single type of event. It could start with a vulnerability exploit, but it could also start with a phishing attack, an insider attack. But what's common on all data stealing and major breaches is that there's a kill chain of events. And the network is the most critical part in that kill chain of events to be able to detect that an attack is going on. They're going to use the network to get in. They're going to move laterally to try to exploit or find, deliver a payload to a container that's running next to you. And then they're going to use the network to exfiltrate the data. Now, in the meantime, they may also be exploiting the container and starting up malicious processes or downloading malicious files. So that's why it's critical, in addition to the network, to be able to monitor the container, process, and file system activity. And so that's what NeuVector provides, is a complete runtime container security platform. We start with auditing and compliance with the Kubernetes CIS benchmarks and runtime vulnerability scanning. And then we provide the network container firewall for segmentation and threat detection, as well as inspecting the container and host process and file system activity. And then we wrap it up with the ability to automatically respond to certain types of events in real time with the appropriate action. So a quick overview of the runtime protections that are provided. So you can see here in my demo environment, if I filter to my demo namespace, I can see here that I've got my workloads. I can see the network connections between my workloads. I can see that Nginx is talking to Node over HTTP, and Node is talking to Redis over the Redis application protocol. And so we've built the network rules to allow the Redis protocol between those pods, as well as the process and file system rules to protect all of these containers. Anytime there's a violation, we're going to be able to detect that. So in this case, it's a network-based attack called the ping death attack. In this case, it's a MySQL brute force trying to guess a password on a MySQL container. And in this case, it's a network violation where the exploit container is not allowed to connect to Redis because there's no rule allowing that connection. So this port scan was detected. And when you're running in protect mode, we can actually block all of these activities. So if I look at all the services running in my containerized environment, I can see that if I look at my Node.js container, I can see that NeuVector has discovered all the processes running in the container and whitelisted those. All of the file access rules, we're also monitoring sensitive system folders, and all of the network rules for connecting to the Node.js pod as well as from the Node.js pod. And as I just mentioned, if you run NeuVector in the protect mode, any unauthorized network activity or file accesses or processes that start to run will be blocked. If you run in monitor mode, we're going to alert you, but we're going to allow that action to take place. So that is a quick overview of some of the runtime protections in NeuVector. Now let's look at how can we automate the creation of runtime security policies. So, NeuVector can automatically discover all that, but let's say you want a fully automated pipeline. In that case, what you're going to want to do is you're going to want to pre-stage or set up those rules prior to deploying your application workloads or your new service. So the workflow would look like you're building your app, you're going to create your typical Kubernetes YAML to deploy that app with the appropriate settings. And then you're also going to create an application security manifest. And what that'll do is it'll create the security policies for that application. So as a very simple example, application security manifest is that it's declarative. So it's in the format of a Kubernetes-native resource. It's protocol-based, so we can say that the application's allowed to connect between the Redis and the Node.js pod. And it's extensible, so you can extend it and then update your manifest. So you're able to deploy the app security policy before you deploy the test app. And optionally, you can use NeuVector to auto-learn the security policy, and that can help your developers and your DevOps teams to know how to create the app security policy. And then, of course, once that all is tested and staging, you can deploy to production. Now, the other thing that we're working on NeuVector is another integration with Kubernetes, which is called a CRD, or Custom Resource Definition. And so what you're going to be able to do is exactly what I talked about, but you're using the Kubernetes CRD construct or capability there. So what you're able to do is you're able to create your security policies, for example, for pod-to-pod or cluster ingress and egress rules based upon applications or ports or IP addresses. And in that way, you're able to define for example, this is a NeuVector security rule, CRD. And in this case, we're going to define a number of services, and we're going to define some ingress as well as egress rules that are allowed to connect in and out of those services. We're also going to define an application protocol that's allowed to connect into or out of those services, as well as, if needed, a port. Now, port in the NeuVector rule set is not needed because we can verify the application protocol. So what you're able to do is you're able to create pod-to-pod segmentation rules as part of your CRD. You're also able to create egress rules to allow connections to non-containerized applications or API services. So you can define these. Then you can deploy your service, and your service will be allowed to connect where it's supposed to connect. You're also going to be able to do these CRDs or specify in the CRD the process and file system rules that we talked about. So with the CRD construct, you can do full runtime security automation. The network firewall rules, all the process and file system rules, vulnerability scanning, the auto response rules to do packet capturing or quarantine, and even the admission control rules that we took a look at are going to be able to be created programmatically and maintained in a Kubernetes-native fashion. Now, we talked about one of the things you could do is an automated packet capture. So this is another automation point that should be considered in your infrastructure. If you do detect suspicious activity on a container, you should be able to then trigger a packet capture of that pod, or grab that network attack if it's a network attack. So with NeuVector, we support both. We will auto packet capture if we detect a network-based threat. And if there's any other suspicious activity, we give you the capability to turn on packet capture for the pod. And of course, we recommend that you just turn that on for a few minutes, otherwise you're going to be generating some pretty large PCAP files. You're also able to set up response rules, which, for example, this says if a container has been modified, the file system in a container has been modified, then let's do a custom webhook to notify, but let's also quarantine that container until we can get in there and figure out what's going on. Now, a lot of you may be considering the service mesh, whether it's Istio or Linker D2, and it's critical for the protection and all of the runtime protections to also work seamlessly in a service mesh environment. So even if you've got encryption on, you've got to be able to inspect your network for attacks. You've got to be able to do packet captures and quarantines and inspect pods, even if it's being protected by a service mesh. So in my demo environment, I can show you here, I've got an actual hybrid environment where I've got some workloads that are running like we see that are not in a service mesh, but I've got other workloads running in the Istio service mesh. So I can easily filter and take a look at these workloads, and I can see, for example, that this is a service mesh pod. I can expand that, and I can see that within that pod, I've got an Istio proxy, and I've got my Node.js container workload. And I can see under the details that within the pod, there's the proxy, and there's the workload itself. I can also see the protocols being used in the pod. So I can see if I mouse over this, that the Redis protocol was being used. And this is even if you've got encryption turned on between your pods. So you can see I have a SSL connection between pods. NeuVector is inspecting all of the network traffic before it gets encrypted by the proxy, and inspecting it on the other end after it gets decrypted. So we're still able to do all of the network protections that I talked about. Now, finally, it's also critical to be able to communicate and automate all of the monitoring that needs to happen. So whether you're using something like a FluentD and Prometheus interface, it's very easy to automate that as part of your deployment as well. So you can see here just a sample YAML file to deploy FluentD, connect it with Prometheus, filter the NeuVector events for certain types of events, and then in this case, implement a custom flow counter that can be graphed in a tool like Prometheus. But if you're not using those tools, we can also export by syslog to your SIM systems, or by webhooks to your Slack channel, or to a special webhook receptor where you can add additional logic. So in the case of the FluentD Prometheus example, you can have pretty much any level of customized monitoring of the security events that you see in NeuVector, as well as the NeuVector infrastructure itself. So finally, at the end of the day, deploying security, whether it's automated or not, it's all about reducing the risk of exploit. So in NeuVector, we're able to, in the 2.5 release, we're able to show you a dashboard. I'm going to show you a dashboard on different infrastructure, which shows a poor security risk score. And security risk in NeuVector is made up of a number of different metrics. Of course, vulnerabilities is an important one, but even more important is, do you have NeuVector turned on to monitor or protect those workloads and those hosts? Because even if you have vulnerabilities, even critical ones in your containers or your hosts, NeuVector is going to monitor those and even block any vulnerability exploit and any network connection that is attempted as a result of that, or any file system activity. So by switching over to monitor mode, you're going to reduce your vulnerability or your security risk. Also, the security risk is determined by the ingress and egress exposures out of your cluster. So if we look at all the different connections that are going out of my cluster as well as coming in, I can review those to make sure that these should be allowed out of my cluster, and therefore reduce my risk. In the 2.5 release, we offer you a wizard that makes it easy for you to improve your risk, to review it. We explain what each of the things mean. And so, for example, if I only allow new services to deploy in monitor mode, not discover, and I switch all of my running containers into a monitor mode, you can see that I'm going to be able to reduce my risk from 60 to 28. So if I click done here, and it's actually gone down to 23. So you can see if I go through that workflow, review my ingress and egress, add some admission control rules, address some of the vulnerabilities, my risk score is going to be decreased. All right, so with all of those automations, NeuVector customers are really using it to varying degrees. Element Analytics in the upper right has a fully automated pipeline. So they do a SaaS service where every new customer that they get, they spin up a new Kubernetes cluster, they automatically deploy NeuVector and its policies, and so everything hits the ground running and the workloads are protected. Other customers are just starting down the path to automation. So, maybe there's automated image registry scanning and the discovery phase for the network rules, and there may be some automated response rules, but they haven't gotten to the automated setup of the network policy every time they deploy a new service. So, it really depends on where you are in your journey to containers, as well as how automated you really want your infrastructure to be. So to sum it up for today, first of all, make sure you understand the level of risk you're willing to take in your deployments. Is vulnerability scanning enough? Are you willing to let high vulnerabilities go into production? Sometimes that's unavoidable, but you can protect against that with runtime protection. If you have sensitive data that you're trying to protect in your Kubernetes infrastructure, then you're going to want to have more in-depth protections. But if you're not managing any sensitive data, then perhaps you are willing to live with less automation. Evaluate your pipeline and your process and look for some of those integration points that I talked about along the pipeline. Where can we automate that, and how can we automate security into that process? And then do it as much as practical. Don't try to have a fully automated pipeline in your first deployment of containers. You may have to have some manually created policies and deployments. And then finally, make sure you lock down your containers with a complete runtime security tool. And as much as possible, make sure you've built in automation to get notified and to respond to critical security events. All right, that's all I had for today. I hope you enjoyed that overview and presentation and demo. Why don't we open it up for questions?
Okay, thank you, Glenn, and great presentation. Sorry for the feedback earlier, but thank you everyone who came together to kind of help us sort this out. Let's open up for Q&A, so please write your questions in the chat box. Okay, Glenn, our first question is, do we have support for Ansible?
Well, we don't have necessarily a plugin or module for Ansible, but everything I showed you in the console and all of the automations are supported fully by a REST API. So everything can be automated in Ansible through the REST API.
Okay, and what does layer 7 security mean?
Yeah, I didn't get too much into the NeuVector layer 7. When I said application protocols, that is layer 7. So when we look at a network connection, we're looking into what's called layer 7, which is looking at application protocols and payloads. And we're able to verify that only the proper application protocols are used between containers. Also, we have announced the ability to look into the payloads and try to detect DLP sensitive data. So for example, credit cards, social security numbers, or other private information that could be exfiltrated, people trying to steal that data out of your network.
Okay, and does your technology work with other platforms than Kubernetes, like Docker or ECS and EKS?
Yeah, we support all of the orchestration tools and platforms, Docker EE, Rancher, OpenShift, Kubernetes, just Docker native, and then all of the public cloud platforms, so ECS, EKS, AKS, all of those public cloud platforms as well.
Okay, and then how do you integrate with Azure DevOps?
So with Azure, of course, we support whether you're running your own cluster, Kubernetes cluster on Azure, or you're using their AKS service. Also, you may be using the ACR registry. So we build all the integration points so that we can scan the registries, we can easily deploy and automatically deploy on a new Azure cluster. If there's any build time scanning that's needed, as I talked about earlier, if you want to trigger that from the build phase, then you can use our REST API to trigger build during the build phase.
Okay, and do you scan both client and server pods?
Yes, absolutely. We scan all the pods that are running in the infrastructure. I didn't touch on it too much, but an important point is not only do we scan all the pods in every cluster, but also the system containers. So those would be the Kubernetes API server if we're running on the master. If you deploy a service mesh, we're also going to deploy and monitor all of the communications between the proxy and the Istio control plane.
Okay, and then is the CRD support for runtime policies available in v2.5.0?
Good question.
2.5.
So we have actually a prototype of that working, but the full support for that will be coming in the next release, probably in about a month or two.
Okay, and then is NeuVector considered part of the DevSecOps space?
Oh, absolutely, yeah. You know, whether it's building security into DevOps, which sometimes people call DevSecOps, you've got to look at security in your entire pipeline, and that's what DevSecOps does. And we, as I talked about, we have a full lifecycle container security platform from the build phase to the ship phase to the run phase.
Okay, and then is there a free trial, or how is NeuVector priced?
Oh, absolutely. There's a free trial that you can contact us at info@neuvector.com or use the demo or trial button on the website. Our pricing model is per worker node or per host that we're protecting in production. So we don't charge by workloads or pods or containers or services. It's very aligned and consistent with all of the like AWS EC2 pricing or Azure pricing or Google pricing.
Okay, and then do you receive vulnerability updates from ExploitDB?
ExploitDB, I'd have to check specifically on that. We get all of our CVE info from all of the public CVE databases, as well as we monitor all of the popular Docker applications. Node.js, for example, has vulnerabilities that are not published as CVEs. There's Java vulnerabilities that we monitor. So we build all of those into our CVE database.
Okay, and how do you handle unverified report vulnerability findings?
We would display the vulnerabilities. If there is a listed fix for that vulnerabilities, we will show that in some of the interfaces that we showed you. We also provide a link out from any of the vulnerabilities we detect to the actual vulnerability disclosure page. So you can click on that, you can research it, and see the status of that vulnerability.
Okay, and then do you receive your vulnerability updates from ExploitDB?
Oh, you just asked that.
Oh, yes, I'm sorry. How do you handle, oh, sorry, yeah, I asked that question too. How often are your security definitions updated?
Oh, sorry, say that again.
How often are your security definitions updated?
I don't know if you mean definitions in terms of rules. In terms of rules for protecting your workloads, like network rules or process and profile rules, those can be updated by you programmatically or through the console, or by putting the service into a discover mode, and then we'll discover those. If you're referring to like vulnerability databases, we update those as often as daily, and the process for updating that is we don't make any SaaS connections out of your infrastructure, so you can run in a completely air-gapped environment. And you control when you pull our updated CVE database, and then we have a little tool to enable you to update that in production.
Okay, and then in addition to that question that you answered earlier about how you handle unverified report vulnerability findings, he's asking for EDB-ID. How does it connect to EDB-ID?
I'd have to get back to them on that.
Okay, sure. And then how do you integrate with Azure DevOps CD pipeline?
I already answered that.
You got that one too? Okay. Some of these questions are popping up again. Is there a way to scan a single container or host instead of the entire registry?
Yes, absolutely. You define in the interface the repository you want to scan, and you could put filters in there to scan all images or a specific image, or you can use wildcards to define just subsets of images or even specific tags.
Okay, and then do you scan for open source vulnerabilities or reports, whether we are running outdated versions of the open source software?
Yes, absolutely. As I mentioned, some of those are showing up in the form of CVEs, and others are just disclosed on those open source maintenance sites in terms of vulnerabilities disclosed. So we monitor all of that and we build that all into our CVE database.
Okay, guys, I think that will be our last question for today. Thank you for all those questions. If you have any additional questions, feel free to reach out to us and we'll answer them personally. A copy of the presentation will be sent to you if you send us a request. Under handouts, we've added the container firewall guide and the customer case study with Vigo. This webinar was recorded and a follow-up email will be sent to you shortly after. All right. Thank you, Glenn. Thank you, everyone. Have a good day.
Thanks, everyone. Thanks, Young.